In this video, you will see how you can conduct a 2x2 between subjects ANOVA in SPSS. This is probably going to be the best choice of test if your study meets the following criteria. When you have two between subjects independent variables, both with two levels. So you want to see whether the combination of each factor affects your measurement. The dependent variable should at least be interval or ratio. And because it's a parametric test, we want to make sure it meets the assumptions. To demonstrate this statistical test, we're going to use data from a real published study who investigated eyewitness testimony and whether it could be biased by an audience member who was present. So they had a relatively elaborate procedure where participants were sat in a room and they had to watch a video of a bar fight between two people, person A and person B. And they were supposedly had to watch a video and talk about what they saw with an audience member who they thought was another participant in the next room, but was actually an audio recording. And what the experimenters did was manipulate two things. First, the audience description, so whether the audience, the fake participant in the other room, was described as a generic student or a law student. The idea here being that a generic student would create a sense of being in the in group, as they was any kind of student just like themselves, or they was a law student to create a sense of an out group, as the participants were all psychology students. It was like a different kind of student to themselves, so they were seen as the out group. They also manipulated the attitude of the audience. So they were described as either positive or negative towards person A in the video. So what they wanted to know was whether the combination of these factors would affect how much they would rate each person on the responsibility for starting this bar fight. So the eventual dependent variable, what we measured, was the relative responsibility between each person. So the responsibility for person A subtracted from from person B, where greater positive values mean person A was more responsible for starting the fight. So the next section we'll see how you can perform a 2x2 ANOVA in SPSS. For a two-way ANOVA, the data will look a little something like this. We have one column for our dependent variable. In this study, it's the relative responsibility, so we can see that it's a scale variable. We then have two columns, one for each between subjects independent variable. So we can see it's labeled as a category, and we can switch between the values and labels. If we quickly go to the variable view, we can see for the audience description, our first independent variable, and audience attitude, our second independent variable, they each have a value and label. So this makes it really easy to switch between a numerical version of a variable and a string version, so we can see what the name of the group is. When we want to do a two-way between subjects ANOVA, the first step is to make sure it meets the assumptions. So we need to go to Analyze, Descriptive Statistics, and Explore. And we will get this menu. So we want our relative responsibility, our dependent variable, in the dependent list box. And then we want both of our independent variables in the factor list. In SPSS, if we put in each one in the factors separately, we will get one part of the output, splitting it by audience description, one part of the output, splitting it by audience attitude. But what we want is the combination of each independent variable. So we want to know for each combination of the two factors, do the data meet the assumptions? So the first thing we want is just the plots for now. We will see the descriptive statistics later on. In the plots option, make sure we untick stem and leaf, we don't need that, and tick normality plots with tests and continue. So if we pressed OK, this is where we would just get one version where it's each of the factors separately, but we want them together. So if we click paste, we can see in this view, this is the syntax underlying SPSS. We don't need to worry about this too much, but what we need, if we have a two-way ANOVA and we want to see the interaction between our variables, all we need to do is enter a little star between the two independent variables. So what this means is it's going to look at the interaction between both of the factors. And this is what we will need in order to split it into each of the individual groups rather than each combination, each variable in isolation. So if we click the big green arrow, this will run that output. So this is the equivalent of when we're in the menu, just clicking OK. And once this loads, we can see we have the output for an interaction. So we can see that for our relative responsibility, we have generic student and a law student for the audience description for each level of audience attitude. So we have 4 groups instead of each factor individually. So the first output we want for the assumptions is the test of normality. So because there are fewer than around 50 participants in each group, we want to focus on the Shapiro-Wilk output. And the idea here is that if it's statistically significant, it means that for that individual group, the data are significantly different to what we would expect under the null hypothesis. And so in this case, something that is perfectly normally distributed. So being not significant would be a good thing here. So it means it wouldn't cross that threshold into be significantly different to normal. But we can see that for 3 of our 4 groups, it is significant. So the generic and negative audience doesn't quite reach that threshold. But for positive, generic, and negative and positive law, they do cross that threshold. So we have some initial evidence that some of the assumptions may not have been met. And we then have QQ plots. So the Shapiro-Wilk, although it's a nice idea, it has some limitations. Because it's based on p-values, it means that it can be very sensitive when you have a big sample size and not very sensitive when you have a small sample size. So one of the things that's a little bit better, but it requires some interpretation, is what's called QQ plot. So this visualizes the idea of these residuals, the difference between what we'd expect under a normal distribution and what we actually observe. And if we have a normal distribution, the dots should fall pretty close to the line. So there's not much difference between the expected under the normal and what we observe. So here it looks okay. There's a little bit of arcing around here, but there is always going to be some random variation. So we can skip through these. Again, a little bit of snaking around at the bottom, but it's nothing too severe. These points are getting further away, so it'd be something we would want to look into. And finally, a similar thing here. So there's a little bit of a distance here. We'll then have what are called detrended normal QQ plots. So these are a little bit harder to interpret, and they're just a different version of the 4 we saw above. So we're not going to pay much attention to these at the moment. The last thing we want is a box plot of the groups and the dependent variable. And we can see here that there don't seem to be any outliers highlighted. It would be a little circle, so there's not too much to worry about here. So although some of the normality may be a problem, we will proceed with the ANOVA for now, but then in the back of our minds, we'll think about whether these assumptions could have an effect on the inferences we make. So we'll return to this later on. So in order to do the 2x2 ANOVA, what we need is the analyze, general linear model, and univariate. Similar to what we put for explore, we want relative responsibility in the dependent variable box, audience description, and audience attitude as fixed factors. They are independent variables. And we want to select a couple of options. So if you have a plots button, we want audience description on the horizontal axis, audience attitude as separate lines. Click add. And again, if you have the option, click error bars, and we want the 95% confidence interval. We also want to go to options. We want our descriptive statistics from a mean and standard deviation, estimates of effect size, and the final assumption we want to have a look at, which is our homogeneity of variance. So if we tick and continue and click OK, we will now get below the original output our 2x2 ANOVA. So we can see we have 20 people in each group. So it says 40 here, but this is for each independent variable in isolation. So within audience description, we have 40 in the generic, 40 in the law student. But then once we split it into our 4 unique groups, we have 20 people. So we can see the mean and standard deviation. We have Levine's test, which we'll explore a little bit later on. Similar to Shapiro-Wilk, the idea here is the null hypothesis is there are equal variance for all of the groups, and a significant result here means that there is a significant departure from this equal variance. So significant would be something that we would worry about and look into more, and we can see here that it does fall below that 0.05 threshold. It is significant. So the variances between the groups are significantly different to each other based on this one method. And another reason for us to think about whether we can double check the results with a parametric or non-parametric test. We then have the main results. So because we have a 2x2 ANOVA, there are 3 effects we need to look at. The first is audience description. So this is there a difference between whether they are described as a generic or a law student? So are they significantly different? Which they are, with a moderate effect size. So this is partial eta squared. There is a significant effect of audience attitude. So there is a difference between positive and negative descriptions of person A. But then there is no significant difference. There's no significant interaction, between the factors. So we've got 2 main effects and no statistically significant interaction, which we'll explore later on when we return back to the output. We also have the plot, which we can tidy up. So this shows us the mean rating for each group, split by the audience description on the x-axis and the audience attitude as separate lines. And we can tidy this up, put it in a report, and it will help to communicate our results to the reader, making sure that we highlight that the error bars represent the 95% confidence interval. Now that we've seen how it works in SPSS, we're going to see in more detail the important output and how the results can be reported. So firstly, for the assumptions, we have normality. So here we have the Kolmogorov-Smirnov test and the Shapiro-Wilk test. We're going to focus on the Shapiro-Wilk as we have fewer than 50 participants in each of the groups. It can be reported like this. So we need the degrees of freedom, the test statistic, and our p-value. And what we're looking for is whether it is statistically significant or not. So whether it was smaller than 0.05. So the first row was not statistically significant, but the next 3 rows were, suggesting that they violated the assumption of normality. these normality tests have well-known limitations. So they are incredibly sensitive when you have a large sample size and lack power when you have a small sample size. So what can be a better option to assess normality is a QQ plot. So here we can see the difference between what we'd expect if the data were perfectly normally distributed and what we actually observe. And if we have a normal distribution of the residuals, we see the dots very close to the straight line. So most of the conditions were okay, but for example, in this particular condition, we have these 2 points which are going further away from the straight line, and it could start to give us cause for concern about whether it met normality. We can question whether there are outliers present in the experiment. So here it doesn't look like there are any issues. This is a box plot of each independent variable for the dependent variable, and there don't appear to be any individual data points highlighted that would cause concern. And finally, because it's a between subjects design, we want to see whether the homogeneity of variance has been met. So here we can see on the top row, based on the mean, it is statistically significant, meaning that we have potentially violated the assumption. You can report it like this. So this would give us another cause for concern about whether a parametric test is the best choice. So although it's relatively robust and we do have equal sample sizes per group, we can see how robust those inferences are for both a parametric and non-parametric equivalent later in the video. The first step to understanding the results is the descriptive statistics. So in the ANOVA output, we can see both the mean for the independent variables in isolation, so these are the totals, and then we can also see for each of our 4 groups, so for generic, negative and positive, and law student, negative and positive, but we can also see the individual means for each independent variable. For the actual ANOVA results, we have 3 effects to report. So we're only going to highlight one here to show you where the values come from. So we have a main effect of audience description. So depending whether they are a generic or a law student, there is a statistically significant difference between those groups. So we can see we need the numerator degree of freedom, which is 1, and the residual degrees of freedom, which is 76. And we need the F value, P value, and partial eta squared for an effect size. And at the end of the video, we'll see how you can report each one. But for now, we're just going to focus on you will need this information for each of the 3 effects. One of the things that's a good idea to report is a visualization of results. So this is often more effective than giving your reader a full page of numbers. So you should be able to report a plot of how the 2 independent variables interact to impact the dependent variable. And on the previous slide, we saw there are 2 main effects. So there is a difference between our description, so between the generic and the law student. And then there is a difference between audience attitude, so between positive and negative. But there wasn't a significant interaction between the 2 independent variables. So because there was some suggestion that the assumptions could have been violated, we can also see what non-parametric tests provide. But one of the issues here is that there isn't directly a way to assess a factorial design using non-parametric methods in SPSS. So instead of focusing on the whole design, what we have to do is break it down and focus on the individual comparisons that are important for our hypotheses. So here we can split it between, for generic students, what is the difference between a positive and negative attitude, and then separately, what is the difference in positive and negative attitude for law students. Depending on what your hypotheses are, is depending which way this splits. You could also do it the opposite way, and for positive attitude, compare generic and law students, negative attitude, generic and law students. It's just important that you perform the appropriate tests to address your particular hypotheses, and we can see how you can use a non-parametric equivalent for these pairwise comparisons. So we'll use the Mann-Whitney U-test, and then return to see what kind of output is important. So because there's potential issues with normality and homogeneity variance, one of the things we can do here is see how robust those inferences are when we double check it with a non-parametric test. So we have to be careful here because we originally wanted to use a 2x2 ANOVA. In SPSS, there isn't a direct way of getting a non-parametric factorial test. So this means there isn't a non-parametric equivalent of a 2x2 ANOVA, but what we can do is look at those individual comparisons. So we can split the file by one of our independent variables and see whether there is a significant difference between each level of the second independent variable. So this means that we're looking in isolation at, say, the difference between positive and negative attitude for generic students, and the difference between positive and negative attitude for law students. So it's really important here that you match this to what kind of inferences you want to make, what your hypotheses were, as there are two ways you could look at this. So you could split it by audience description and then focus on audience attitude, or you could do the opposite and split by audience attitude and enter audience description as your independent variable. So this is going to switch which way round you compare the groups. So make sure that this is consistent with what kind of hypothesis you're wanting to address. So if we go to data and split file, we're going to use audience description as what we want to compare our output. So we click organize output by groups, audience description, and click OK. So we now have split the file. And now what we can do is run a non-parametric test. So in this case, we're comparing two groups. So we're going to use a Mann-Whitney U-test. So if we go to non-parametric tests, legacy dialogues, and two independent samples, because we are comparing two groups, relative responsibility is still our test variable, our dependent variable. And we are going to enter audience attitude as our independent variable. So if we have group 1 and 2, this needs to match the values you've entered for the variable, which you can see in the background. So we're comparing 1 and 2. Making sure that Mann-Whitney is ticked, and click OK. Because we've asked it to split the file, we get two outputs. So one where the audience is generic. So we can see that here there is a significant difference between positive and negative, where negative attitude has a higher mean rank than positive. So that means that there is greater responsibility for person A when they express a negative attitude for a generic student. And we can report this as a Mann-Whitney U, as we normally would. And we then have separate output for focusing on law student as our second group. So here that we can see the effect is non-significant. So there isn't a significant difference in relative responsibility between negative and positive attitude when we are just focusing on the law students. So after looking at the process in SPSS, we can see that we need two tests to cover the two pairwise comparisons highlighted here. So we have one for generic students, which was statistically significant, And then to demonstrate the Mann-Whitney test for the law student, we can see here that it was not statistically significant. We can also report R as a non-parametric measure of effect size, and it's not reported directly in SPSS, so what you need to do is divide the Z value by the square root of the sample size, which in this case it's 40 because we're focusing just on the law students, and there are 20 participants in each group, 20 in positive, 20 in negative. If we're just focusing on the parametric version, we can report the results a little something like this. So we report there is a main effect of audience description and describe what those group means were. So for generic student and the law student, there's a main effect of audience attitude, and again, report the descriptive statistics for negative and positive attitude, but there wasn't a significant interaction between our two independent variables. If there was, you could then break the descriptive statistics down for each of those group means instead. And if you're interested in the full original article, you can find the reference here.